The green tech main stage now is welcoming Viscon to join us for mastering the horticulture process. And this time we're talking about hydroponics very specifically. Maren Schoormans, welcome to you, and Simon Kleinjan, welcome to you.
Thank you.
You're, of course, both experts in this area, and we're going to be talking about the importance of horizontal farms.
Indeed we are, because there's a lot of attention for vertical farms, and I enjoy that because it's an exciting development. It's new territory, so to say, for fresh marketeers, for engineers, for investors, for growers. But let's not forget that greenhouses can be very efficient and very profitable. That's why we're here.
That's why we're here, and hydroponics play an important role. Why?
Because if you talk about leafy vegetables or vegetables in general, most of it is still grown in the soil, and sometimes with very unsustainable ways of growing, like using furrow irrigation or sprinklers. So in the next decades you will see a transition from the soil going to soilless environments, and there's various forms of soilless growing on the market, and the one that we believe in is deep water culture, actually growing on a pond.
Growing on a pond, Simon. Sounds relatively simple. What's the journey been like to get to the solution which you have today?
Well, to go on a deep flow system is that is a better condition for the plant. So you don't have any kind of drying out of the plant. So there's sufficient water. The plant has sufficient nutrients to grow, and we use also the water to float. So we have also the transport system. So we put them on one way in the pond, and they go out on the other end when they are ready for harvest.
Okay. As I said, it sounds relatively easy and simple. Was it easy to develop?
It was quite a long way to get there. So we learn every day. So we are almost over 10 years in the hydroponics.
Yeah.
And so we have had some obstacles, I must say. So, yeah.
Like any new invention and innovation?
Yeah, it's also about water quality, to keep that good under control.
Yeah.
And now these days we have succeeded in that. So we have a proven concept for the water quality, and that's the big thing in the whole system. Yeah.
Okay.
Automation is in our DNA, so that's not the biggest problem.
Yeah.
So with the cranes and conveying systems, we are used to that. So we have realized several projects already. But the water quality, there are so many things around it which can go wrong. So we learned a lot in the last years, and now we have a perfect system that we are ready to scale up.
Understood. But Maren, this has already been installed, it's already in use. Maybe we can see it on the monitor right now, a hydroponics bed. Is that what we call it in the industry, a bed?
I would call it a pond with floats or rafts, if you will.
Yeah.
And this is a beautiful example. It's actually in Bulgaria, one of our customers has a very high yield. And as Simon indicated, it was a challenge to keep algae away from the water, or to prevent that it gets out of hand, and also pathogens. So these days there's all sorts of technology, and that is the strength of the Viscon group. Because we're on the lookout for new technology, we try it, we implement it, we make a total solution, and that's why we're here, because we're ready to scale this up massively. So shall I tell you about the solution a little bit?
Yeah, and I'd like to learn especially about the Bulgarian application which you have here, but tell us about the solution first.
Yeah, I actually brought some water from our pond. We have a test facility in Schravendeel, a tiny little village south of Rotterdam.
Okay.
And we're running that system for quite a while now, without cleaning the pond, so to say.
Yeah.
In the most challenging spring and summer we've ever had in the Netherlands. It was hot, it was dry, it was plastic greenhouse. So it was an ideal test facility. And as you can see, it's clear.
Yeah, but otherwise you would expect algae to grow out of control very, very quickly as well.
Oh yeah.
Yeah.
So I don't know if you can zoom in on this bottle, but even if you can zoom in, it will be very difficult to see, because there's tiny little nano bubbles inside the water.
Nano bubbles?
Nano bubbles. microscopic bubbles. The size is, if I'm correct, Simon, 40 nanometers.
Nanometer, yeah. For as an example, hair is 80,000 nanometers.
I was going to say, it sounds
So
like...
you cannot see them with your eyes.
No, no. Okay, and what are they for? They prevent algae formation?
Actually, they do, but what the brilliant idea is behind it, and we're not the only ones that use nanobubbles. I think that will be one of the big developments in the next years in horticulture, every application. The thing is that you can oxygenate the water. You can make sure there's enough air dissolved in the water without the bubbles going to the surface. Because a nanobubble has a completely different physical property than a normal bubble. Normal bubble would pop out even in 30 degrees water temperature.
Yeah.
We had 3 times the saturation level of oxygen that you would normally have with regular oxygen, thanks to the nanobubble.
Yeah.
And we added some technologies to that. But that is something that I'd like to talk about with any customer or someone who's interested to come over and see how we've done that, because that's a little chef's secret.
Okay. So a bilateral conversation is what you're offering there?
Oh, for sure.
Okay. Okay. And where can we see this in action in the Netherlands?
You can see a small version in 's Gravendeel, which is half an hour from the center of Rotterdam.
Yeah.
That's where we are. That's where we make our machines, we make our equipment.
Got it.
That's where we live.
Got it. Good. Simon, how did you come up with the idea of nanobubbles?
Also, long journey. So you try a lot of things. So ultrasound bubbles and all kind of sorts. And then someday you walk into this and you try and try again and to scale it in the right conditions. So that's how we came to this system.
This is why the test facility is so important, to be able to work out all of these different...
Try a lot of things, and before we did the trial at customers, but it's always a long journey to get there to the customer.
Yeah.
You don't have the right backup of the customer. So now you have everything in one small demonstration greenhouse behind our company. We do all the tests ourselves. And that's for us the best solution.
And we have a question from the audience from Ken Coles. Thank you, Ken. How do you create nanobubbles? Is it with a Moller nanobubbles generator? Or is this one of the things that would happen in a bilateral conversation?
It's one of them. But,
It's one of them, but we have looked into that. But we have a separate system, which is in our mind, it's a more fine nanobubble than the Moller unit produces.
Okay, so even finer.
Even finer. We have added another unit to that, which makes that we have healthy water, that we keep out the algae.
Yeah.
And to keep out also the pathogens.
Okay.
Yeah.
Let's talk about yield a little bit, if we can. Hydroponics in general, but also your solution with the nanobubbles. How does it compare to more conventional ways of growing lettuce?
Well, it's a big step upwards, I would say. So if you look at the world lettuce market, if I remember correctly, the average yield, but there's a lot of low-yielding surfaces actually. The average yield is something like 2 to 4 kilos per square meter, if you're a good grower. With this system, of course, depending on your equipment, well, let's take the upper end of the spectrum. Then we're talking about this raft system on a larger scale, fully automated, with artificial lights in the Northern Hemisphere, so good climate. You can go as high as 120 kilos of lettuce per square meter a year. That's huge. So we're talking, when you look at the investment, you're talking about a cost price that is somewhere between 35, 40 euro cents. I'm looking at Simon, if you check the numbers a little bit, which is highly competitive. And actually there's lots of messages on the internet on hydroponics with calculations of price and comparisons to outdoor fields and to vertical farms. But actually, we learned from our experience with our clients that hydroponic growing is much more competitive actually when it comes to return on investment than people believe.
Okay, and is it less labor intensive, or for example, I assume there's less cleaning requirements, speaking naively?
Compared to...
You don't have soil?
Exactly. Well, you don't clean the soil, actually.
No, you clean the lettuce off the soil and the sand and...
Well, there's no sand.
Yeah.
That's right. So you don't have to wash the lettuce. You can actually pick it up with a harvest machine, with a harvesting machine that we make. But when you harvest a big head of lettuce, you always have to trim it a little bit because the bottom leaves, the bottom 2 leaves, can have a bit of yellowing. That is normal with every system.
Yeah.
So there's always manual labor required, but the labor required is very low.
Okay.
Yeah.
Good. Simon,
Yeah.
we have a question from Rob Veenstra. Is it working on every level of water, or does it have to be deep water?
We have chosen for the deep water system because we have then the automatic cranes to place them into the pond and out.
I'm sorry, the automatic cranes?
Crane system to
Yeah.
lift the floats out of the pond and to place them into the pond.
Yeah.
So we need a certain level of water to get under it. There are roots under it. They are not going straight down because they are floating in the water. But still we don't want to damage them. And the thickness of the layer of water gives also a certain stability to the system. So to control the water quality, but the temperature, of course.
Because you've got a larger mass of water in which the lettuces are floating.
And if I have a thin layer of water, the temperature goes pretty quickly up and down.
Yeah.
When the sun is shining, it can go up easily in a thin layer of water by 20 degrees.
Okay, but we're talking, what, 30 centimeters is what your
pond
hands were showing me?
construction is around 30 centimeters, but the really water level is around 25 centimeters.
Okay, okay. And what is why would you not do deep water? Is that a question of stacking in a vertical farm?
Yeah, you can make it again much deeper, but then it's too much water to maintain. And a thin layer of water, you have not enough oxygen in it. It gets hot very quickly.
Yeah.
And so for the automation all together, the roots have to swim in the water. Yeah, so that's why the 25 centimeters is just a perfect depth.
Good. A quality question from Jorge Arteaga. How long can the system maintain good quality water? Is there a need to flush it out, to refill the ponds? What do you do there?
Good question. We always said we have to clean the pond once per year.
Once a year.
But now we try to not use substrate like peat. So we use more clean substrates like oasis or foam. Rock wool is also possible. Obturo, that's the kind of plug which we use lately. So these don't melt in the water that you have a lot of dirt in. And that's why we keep the water already cleaner. I think the latest water we had in this unit, it has been in for 1.5 years minimum.
1.5 years at minimum. Okay. And what about, let me extend that question, then we have another one. What about the in-feed water quality? How do you assure that? What do you do there? Is it different in different regions, I assume, etc.?
Yeah, and a good question also. It can be water from a source, or from rainwater, or sometimes from a river.
Surface water.
So then the supply water needs to be clean. Or you have to use a kind of a reverse osmosis when there is too much dirt in.
Yeah.
So the intake water which we use...
remove the salts.
Yeah. So our intake water is just fresh water without any nutritions.
Yeah.
We only fill what we lose per day for evaporation and for growing of the product. And we maintain the water in the pond a couple of times per day for temperature, EC, pH to control it. And
can the discharge every 1.5 years, can that be reused? Or what happens with that?
The water can be reused,
through the same filtration system or water treatment system for the in-feed,
Exactly.
Okay, good. Another question from Ken Coles. Is there a small application for small productions, or is it just a very large application? I think like we see here from Bulgaria. That's the first question to you, Maren. And can it be purchased from or via Viscon? And is it a Dutch product? How do you get hold of a solution from this? And I think the question is as well whether they can get hold of a nano bubble generator. But we'll ask that of Simon in a moment. Firstly, small applications, and how do you get it from Viscon? And can someone buy the components maybe to build their own system?
Several questions rolled into one. So yes, it's very simple to obtain such a system. And we make it in the Netherlands. We construct it together with partners. We can even supply the whole greenhouse and everything around it. That's no problem whatsoever. So how small can it be? Well, we do systems from 1,000 square meters. We can do them hectares. But we're very fond of the little systems of a couple of thousand square meters. We have experience with that, and we have a very straightforward way of automating this. We use a monorail with a little manual crane. We use a smaller washing machine for the floats and for the trays. We have a little area for, well, I'm talking like a little, it's not a toy, but it's a professional installation, of course, with a high yield. But yeah, we specialize also in the small ones, for sure. So come to us, and we'll help you.
Okay.
Yeah.
A lot of questions around the nano bubbles. It's gained a lot of interest. How do you use pure oxygen and inject it into the nano bubbles for the water? And how long do the bubbles stay in the water? You're talking about them not rising to the surface and popping.
Yeah.
So is it forever?
It's not forever, but once the unit is running, we make levels far above the 100%. So we're even above 200% oxygen. And we are looking into do it temporary. So we do 24 hours a day oxygen. So it's not really a must. So it's also safe. If you have a cut of electricity and the system is not running, it will stay in for a week.
For a week,
Yeah.
okay. And you're using pure oxygen, which is generated on the site?
We use oxygen from the air.
Yeah.
And with the unit we make it on a high level, high concentration of oxygen. And then goes to a nanobubble generator, which is making the very fine bells in the water. And these are charged with clean air to disinfect the...
So everything is produced on site, and you basically just need the bubble generator with electricity.
Yeah.
As long as you got electricity once a week, you're okay.
Exactly. So it's not the same as putting the compressor on the water, because that's using a lot of energy.
Yeah.
And that was also a big advantage of this system, that we use a very low amount of energy. Yeah.
Excellent. Okay, let's move to the future. Where do you see things coming to play? We have some clients here in Europe for the moment, at least. Where do you see a geographical focus for expansion and scaling this up? And maybe what are some of the technological developments moving into the near future?
Well, geographically, I would say almost everywhere. But you know, there are some climates like the Gulf area, Gulf region, where it's very hot. There's climates where it's very hot and very humid. It's extra difficult for a greenhouse cultivation, where you would rather have a vertical farm. If you would build something in very expensive square meters in the middle of a city, you would rather have a vertical farm. That's why I'm saying it's a very exciting development. But otherwise, you can put this anywhere. We've put this in several places in Europe, North America, Southeast Asia. You just add to the list, Simon, because you've been with the company longer than I have.
Yeah, exactly.
The second question, what was it, Andrew?
The second question,
oh, yeah, innovation.
Around innovation and the future and what's going on. And
it's been a long day.
It's okay. Are there other crops that you can perhaps as well consider for this application?
Well, as long as the crops don't grow too high and tip over, you can grow anything. We've grown Asian spinach and herbs and leafies, all sorts of things you can grow on that.
Chinese cabbage, pak soy, and these varieties.
Oh yeah, I would even consider medicinal cannabis. As you can get rid of, I don't know the English word for water lice. It's a little pest that attacks the roots.
Water lice, yeah.
And apparently they can't swim. So it's something we have to look into. And when you talk about innovation, I would say it's anything that has to do with controls. So making sure that everything is visible, controllable, manageable, dashboards, collecting data from sensors, but also organic fertilizers, for example, and combinations with aquaponics, for example. So there's all sorts of things we're looking into. We're doing experiments. So you can expect something from us in the next couple of years, that's for sure.
Those sound like perfect concluding words, gentlemen. Thank you very much for introducing the hydroponic solution which you have here. The best of success with everything. And thank you for being here with us.
My pleasure.
Yeah, no problem.
Thank you.
Thank you. Thank you very much.